Hello, hello, Shagat the Known here. Welcome back to another Rust coding stream where we are doing this roguelike tutorial in Rust. Today is the 3rd of October 2022. Local time is 16:30 on the dot. Well, not on the dot, 48 seconds past. All right, enough of being goofy. Let's get started. I have a terrible headache. Hopefully it goes away. I considered not doing this because of it. If it gets bad enough, then maybe I'll call an audible or something, but we'll see how it goes. It's just been, it ramped up a little afternoon and it hasn't left yet. So it's like, ah, man, it's killing me. I like stepped away from the computer for a bit and all that. Still no dice. Anyway, like I said, let's get to it. So last time we went through like the initial introduction here and well, it keeps like lagging a bit. There's some weirdness going on there. As I'm mousing over this, I can, I had to replay. Like I'm waving my hand and I'm seeing it lag as well. But it's only happening when I'm like mousing over these. See the mouse lagging as well. That's odd. Okay, something to think about and look into. Don't know if it's anything I can fix, but it's good to know. Okay, so last time we did the basic introduction stuff and we set up the entity component system specs. Now today we're going to look at what we call walking a map and then a more interesting map. I'd like to try to do both of those. Might do the field of view, but I'm leaning towards no depending on how long these take and depending on how I'm feeling. So we'll see what happens. So skipping the intro because it's the same every time. The remainder of this tutorial will be dedicated to making a roguelike. Rogue, we have a Wikipedia link, appeared in 1980 as a text mode dungeon exploration game. It has spawned an entire genre of roguelikes, procedurally generated maps, hunting an objective over multiple levels, and permadeath, restart when you die. The definition is the source of many online fights. I'd rather avoid that. And then, and aside from the tutorial, you also have the debate of roguelike versus roguelite, because it's like, well, it has some elements of a roguelike, but it's different. It's not really a proper, pure roguelike. So you get into those debates too. A roguelike without a map to explore is a bit pointless. So in this chapter, we'll put together a basic map, draw it, and let your player walk around a bit. We're starting with the code from chapter 2, but with the red smiley faces and their leftward tendencies removed. Well, that's the perfect opportunity to go back over here and just show that one more time before we lose it. And there we have it. That kind of hurts my eyes to look at right now. So we're going to remove, we shouldn't need left walker and left mover. And we shouldn't need that system. I'm assuming we don't need any of it, so I'm getting rid of it. If it turns out that I do need it for some reason, then I'll add it back. So then anything that uses like left mover is gone. They no longer have, actually we're removing the red smileys altogether, so we don't need those. Let's see. We're having some complaints up here. We no longer have that system. So we'll get rid of that. And we're basically running an empty system now. It still move though. So everything is good. Okay. Now let's get back over to it. So first, we're going to define the map tiles. We'll start by allowing 2 tile types, walls and floors. We can represent this with an enum. To learn more about enumerations, the Rust book has a large section on them. And we're going to derive partial EQ, copy, and clone. We're going to make an enum called tile type with wall and floor. So I will put that, I'll just put that like right here. tile type, and then it's going to have wall and floor. Simple enough. Didn't even have to read it. Notice that we've included some derived features, more usage of derived macros, this time built into Rust itself. Copy and clone. Clone adds a .clone method to the type, allowing a copy to be made programmatically. Copy changes the default from moving the object on assignment to making a copy. So tile1 equal tile2 leaves both values valid and not in a moved from state. Partial EQ allows us to use double equal to see if two tile types match. If we didn't derive these features, if tile type double equal tile type wall would fail to compile. So basically you can't do the double equal comparison is what we're saying. So building a simple map. Now we'll make a function that returns a vector of tiles, representing a simple map. We use a vector size to the whole map, which means we need a way to figure out which array index is at a given xy position. So first we make a new function, xy_idx, or index. And this is something I think I've referenced before, how you can, instead of using a two-dimensional array, you can use a one-dimensional array or vector, and you can do some math to index into it as if it's a two-dimensional. Data is data, and as long as you access it in a consistent way, then it's perfectly valid to do that. So we need, I'm not sure why it's pub function, but we'll do what's listed here. XY index, X I32, Y I32. Shouldn't need to make a pub function unless it's inside of a of an impl block, and maybe that's the idea, is it is in an impl block somewhere, but it does not show that on the code here. So what we do is we say y as usize times 80 plus x as usize. And that's all there is to it. It's very simple, but it's worth understanding. And I actually want to up the size on this by 1. It's really large on my screen, but I think it's better for viewing. And we'll actually shrink that. Actually, I could probably just disable that and it'll be even better. Okay. And we're getting complaints that certain variants are not used, but that's okay. So the way to think about this is we have some, let me draw out a little picture here. We have some little like array right here. How many is that actually? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have some like array here. I'm just putting X's to mark it. Normally we would think of this as a two-dimensional, actually let's do something a little bit smaller. We're gonna do a 3 by 3. Because it's just a little easier to represent. So we have a 3 by 3 here. And then down here we have just 9, right? So what, we don't need comments there. 1D, 2D. And so the idea here is normally, you know, you might think of this as a two-dimensional array where you say, oh, we need like X and Y values. It's two-dimensional, so it's like an array of arrays or a vector of vectors. And that is valid, but there is a common technique. I learned about this when I was doing C programming in university early on, and I can't remember, I never remember if it's called row major or column major order, because you can do it like two different ways. But the idea is, instead of making a 2D array 3 by 3, you can make the 1D array of just 9 elements and then index them into them in a certain way with an X and a Y value that treat it the same. So what we're looking at here is if we have this here, well, like this spot's easy. It's like 0, 0, right? And then this spot here is what, 0, 1, 0, 2, and then 1, 0, 1, 1, 1, 2. Easy enough, right? We want to be able to turn those same values into something here. So the thing to recognize is that, like, how you can kind of begin to derive this is you want to think about what row you're on. And recognize that there are some number of things on each row and use that to derive the formula. And that's what we have here. So we have 80 things per row. And the way to say it is it almost feels a little bit backwards, but you're actually counting the columns, right? Because that's how many things make up a row. So our terminal is 80 characters wide. So what we're doing here is saying, okay, this gives us like which row we're on, kind of, because we say, oh, if we are on number, well, like in this example here, if we're going for number 0, 0, that's easy, right? But if we're going for 0, 1, that's just index number 1 here. If we're going for 0, 2, that's index number 2 here. But then this is where it gets interesting. When we go to 1, 0, that's index number 4 here. And the way we map that is, instead of 80 here, we would say, okay, we have 3 things per row. So we say whatever the y coordinate is times 3. And in that case, and then like plus an x value, right? So this is actually index number 3 here that we want to get to. So because we're now on this second row, we end up with 1 times 3 plus 0. And it might not make a lot of sense. Might be going too in depth on it. My headache might not be helping. Because I feel like I am talking a little bit in circles. But the idea is basically that this part here is telling us what row we're on. And in this part here actually kind of tells us the column, because it tells us like how many extra elements we've moved into the row. So it's a bit of an interesting way of looking at it. I recommend, like, you know, maybe drawing out a picture of your own, kind of like what I have here, and like looking at how different indexes work in both cases. Like take the formula y times, you know, whatever. So in this case, the width would be 3. So take that formula y times 3 plus x and see how it maps between the two. And that'll give a better indication of how it works. But again, let me do one breakdown on the numbers I was just saying. So if we want to get to element, let's see, 1, 0, that should map to index 4. And so we have y would be 1. Yeah, y would be 1 times 3 plus 0. Or if we want to get to element, you know, 1, 1, that should give us index 5. And the way we could think about it in this 2D case is just say 0, 1, 2, 3. Oops, I said 5. It should be 4. I actually was... told you my head is just throbbing. Well, it'll get better. It actually is starting to get better now that I'm doing this, but I am just like sweating. It's miserable in here. So we start here, we say 0, 1, 2, 3, and that's what we have here, 1 times 3 plus 0. So here we're going to have 1 times 3 plus 1, and that's going to get us the index 4. And then we do that again for this row here, and we're going to get indexes, what, 6, 7, and 8 for the last row. So that's it. I'm not going to break that down anymore, but that's how this thing works. You might see it in a lot of C code where it's just preferred to use a single dimensional array instead of a 2D array. And I've done that. I've derived that in the past because I was like, I can never remember. So it's a quick little exercise. Just think about what times what plus what. It's not that bad once you get used to it. So anyway, and then they're just describing it in very quick words here, but I wanted to try and like link it to a picture. So they say this is simple. It multiplies the y position by the map width and adds x. This guarantees 1 tile per location and efficiently maps it in memory for left to right reading. We're using a Rust function shorthand here. Notice the function returns a u size equivalent to size t in C, C++, whatever the basic size type used for a platform is, and the function body lacks a semicolon at the end. Any function that ends with a statement that lacks a semicolon treats that line as a return statement. So it's the same as typing return y is usize times 80 plus x is usize, semicolon. This comes from the Rust author's other favorite language, ML, meta language, which uses the same shorthand. It's considered rustation, canonical Rust. I always picture a Rust monster with cute little claws and shell to use this style. Okay, that was a weird... It's considered rustation to use this style, so we've adopted it for the tutorial. And then the little thing there was saying rustation means canonical Rust, and that they always picture the little Rust monster. And then we write a constructor function to make a map. Okay. I was going to say ML is meta language. I'm having serious deja vu. I know we didn't do this last time, but I'm having serious deja vu for some reason. Like this exact thing. And I think I just skimmed over it last time after the coding stream, and maybe that's why. Because I know I didn't do it. We still had the other stuff from the ECS. So now we're going to make that function here. We're going to say new map. I did my favorite typo, N32 instead of new. So we're going to have a vector of tiles. We're going to start by making everything the floor. So this is actually a way we can initialize something. And we're basically saying we need 80 times 50 tiles because that's our console width and height. And then we need, we want to initialize all of them to tile type floor. So that's all there is to that. Pretty straightforward. At the bottom here, I'm just going to go ahead and return map so it stops complaining that, what's it say? Mismatched types. Because right now it thinks we're returning the unit type, the unit tuple or whatever. I don't want it to complain while I'm writing the rest of this in. So we're going to return the map. That's what we're going to end on anyway. So that's fine. We're going to make the boundaries. Walls. Okay. So for x in 0 to 80, map x, y, index, we're going to say x in 0 equal tile type wall. And 49. So this is pretty simple. We're going to copy this for the y value because it's going to be almost identical, except we're going to go 0 to 50, I imagine. And we're going to say 0 and 79. And actually, we're going to need to swap those around, though. Y and Y. We are literally taking the border of the console. That's all we're doing here, right? So 0 to 80 says take all the x values and basically run across the border of the y values at 0 and 49, and then do the same thing for y. You know, fix the x values to 0 and 79, and then run through all the y values on that edge. Pretty straightforward, not much going on there. Now, randomly, okay, that's a long console. I'm not gonna, or that's a long comment. I'm not gonna type that one. So we'll randomly splat a bunch of walls. It won't be pretty, but it's a decent illustration. So first, obtain the thread local RNG. So we're gonna, okay, we have a random number generator that comes with RLTK, and we're gonna make a new one and store it locally. So 4_i in 0 to 400. Now we'll see why these numbers were chosen, because I'm actually curious about that. Let x equal RNG dot roll dice 1 to 79. And we're going to do the same for y, except it's going to be, I imagine, 1 to 49. Yep, 1 to 49. And then index, let index equal xy index with those x and y values we just made. And if index not equal to xy index 40 and 25. So I think what's happening is we're hard coding a few things, and I know that's going to be changed. I frown against it, but I know it's going to be changed because I'm recognizing what these numbers are. 40 and 25 represent the midpoints, right? 40 being half of 80, 25 being half of 50. I'm too lazy to do the math, but 80, no, that's right, 8 times 5, yeah. 80 times 50 is going to be 400 or 4? It's 4,000, right? I guess, well, we don't want to do every tile, right? So we just want to take a tenth of the tiles. Yeah, so we're taking a tenth of the tiles at random and just making them walls. I guess that's what we're doing with that hard-coded 400. So you could also do something like 80 times 50 divided by, or times, well, you wouldn't really be able to do that. You'd have to cast it as a float and do times 0.1 and then turn it back into a whatever. I'm not going to do it, but the idea is you could calculate that instead of hard coding it. And similarly for like the center here, we're basing it heavily on the console is what I'm trying to say. The size of the window rather than actually calculating it. And I know we're going to change that because I've skimmed enough of the tutorials to see that at some point we do decouple from the terminal. So I know it's going to happen. It's just not an immediate thing. And it's fine for now. It's just something I want to call out. Just point out. So yeah, there's a fair amount of syntax that we haven't encountered before here. So let's break it down. So fn new map vectile type specifies a function named new map. It doesn't take any parameters, so it can be called from anywhere. It returns a vector. A vector is a Rust vector, or we'll say vec. Vec is a Rust vector. If you're familiar with C++, it's pretty much exactly the same as the C++ std vector. A vector is like an array. See this Rust by example chapter, which lets you put a bunch of data into a list and access each element. Unlike an array, a vec doesn't have a size limit, and the size can change while the program runs. So you can push, add new items, and remove them as you go. Rust by example has a great chapter on vectors. It's a good idea to learn about them. They are used everywhere. Next, let mute map equal vec tile type floor 8050 is a confusing looking statement. Let's break it down. Let mute map is saying make a new variable, let me change it, mute, and call it map. Vec is a macro, another one built into the Rust standard library. The exclamation mark is Rust's way of saying this is a procedural macro as opposed to a derived macro like we've seen before. Procedural macros run like a function. They define a procedure, they just greatly reduce your typing. The vec macro takes its parameters in square brackets. The first parameter is the value for each element of the new vector. In this case, we're setting every entry we create to be a floor from the tile type enumeration. The second parameter is how many tiles we should create. They will all be set to the value we set above. In this case, our map is 80 by 50, 4,000 tiles, but we'll let the compiler do the math for us. So we just need to make 400 tiles. You could have replaced the vec call with for underscore I in 0 to 4,000 and then map.push. In fact, that's pretty much what the macro did for you, but it's definitely less typing to have the macro do it for you. So for x in 0 to 80 is a for loop, see here, just like we used in our previous example. In this case, we're iterating x from 0 to 79. And then map xy index equal tile type wall. First calls the xy index function we defined above to get the vector index for x0. It then indexes the vector, telling it to set the vector entry at that position to be a wall. We do this again for x and 49. We do the same thing, but looping y from 0 to 49 and setting the vertical walls on our map. Let mute RNG RLTK random number generator new calls the random number generator type in RLTK's new function and assigns it to a variable called RNG. We're asking RLTK to give us a new dice roller. And then for underscore I in 0 to 400 is the same as other for loops, but notice the underscore before I. We aren't actually looking at the value of I. We just want the loop to run 400 times. Rust will give you a warning if you have a variable you don't use. Adding the underscore prefix tells Rust that it's okay, we meant to do that. As a side note, you can actually omit the I, and typically people do, and they'll just have an underscore, not an underscore I. But that's perfectly valid. It's not bad. It's just maybe considered a little less idiomatic. So let x equal rng.roll dice 1 to 79, calls rng. We grabbed in 7 and asks it for a random number from 1 to 79. RLTK does not go with an exclusive range because it is trying to mirror the old D&D convention of dice being 1d20 or similar. In this case, we should be glad that computers don't care about the geometric difficulty of inventing a 79-sided dice. We also obtain a y value between 1 and 49. We've rolled imaginary dice and found a random location on the map. So we set the variable in idx to the vector index via xy index we defined earlier for the coordinates we rolled. If index is not equal to xy index, 40 and 25, which is the exact middle, which is where we're going to be starting, we don't want that to be a wall. So if it isn't the middle, we set the randomly rolled location to be a wall. It's pretty simple. It places walls around the outer edge of the map and then adds 400 random walls anywhere that isn't the player's starting point. Now, I could run the code right now, but it's going to be useless because we can't see the walls and we can't have any interaction with the walls or anything. It's just data that's not being represented or anything yet, right? So we need to actually do something with it. So making the map visible to the world. Specs includes a concept of resources, shared data the whole ECS can use. So in our main function, we add a randomly generated map to the world. So where do we want to do that? Let's see, where are we adding things? We'll probably do it right here. gs.ecs.insert new map. And I guess it's a generic function, yeah, so it just figures it out. I like that. Every type satisfying any plus send plus sync automatically implements resource. This can be added. Cool. I like that. So the map is now available from anywhere the ECS can see. Now inside your code, you can access the map with the rather unwieldy let map equals self.ecs.getMute, vec tile type, all that fun stuff, right? It's available to systems in an easier fashion. There's actually several ways to get the value of map, including ecs.get, ecs.fetch, .getMute. GetMute obtains a mutable variable. Let's try that again. GetMute obtains a mutable, you can change it, reference to the map. Wrapped in an optional, in case the map isn't there. Fetch skips the option type and gives you a map directly. You can learn more about this in the specs book. So now we're going to draw the map. Now that we have a map available, we should put it on the screen. And the complete code for the new draw map function looks like this. Let's write it right up here above. We'll write it next to the make map, to the new map. It was called make map in the last tutorial. So we're going to have the RLTK context coming in. And we're going to take the map as a parameter. That all makes sense. And we're going to use the context to draw it. Right, because the context allows us to call some functions on the, like some draw functions and all that. So for tile in map.iter, render a tile depending on the tile type. Match tile. Actually, I'm going to shorthand this and just fill the match arms because I get that for free. So we're going to do, except they reversed them. So how do I do this? There we go. They have them in the other order, so I'll do this so it's easier on the typing here. I'm not having to flip what I look at. So we're going to do an RGB from F32, which I guess usually that means it's 0 to 1 are the values you care about. So we're saying that's like a gray color, right? It's just gray. 0.5, 0.5, 0.5. This other one is going to be 0 dot 0 dot 0 dot. I've never seen that syntax before, but I guess it works. I usually do 0 dot 0. 2CP437, and it's going to be that right there. Now we're going to copy that and plop it in here for wall, because not much is going to change for the wall. It's going to be the color 0.0, 1.0, and 0.0, and it's going to be a pound sign. Okay, and then after the match, we're going to move the coordinates. What do we mean by that? Oh, if x is greater than 79, I think I know what they're doing. What we're doing, I see. I see what we're doing. Yeah, because we're using, okay. We're using that x and y value that we define at the top. And we're manually, we're basically manually changing these variables because we're using them to index, right? To represent the index? Or are we? Hang on. Yeah, no, we are. Okay. Yeah, we're using them in the CTX to represent the index. I just auto-formatted there. A little bit better than the really long line. Okay. So this is mostly straightforward and uses concepts we've already visited. In the declaration, we pass the map as an ampersand tile type. Like, looks like an array, it's a slice, rather than an ampersand vectile type. This allows us to pass in slices, parts of a map if we choose so. We won't do that yet, but it may be useful later. It's also considered a more rustic, that is, idiomatic Rust way to do things, and the linter Clippy warns about it. The Rust book can teach you about slices if you're interested. Otherwise, it takes advantage of the way we're storing our map, rows together one after the other, so it iterates through the entire map structure, adding 1 to the x position for each tile. If it hits the map width, it zeroes x and adds 1 to y. This way we aren't repeatedly reading all over the array, which can get slow. The actual rendering is very simple. We match the tile type and draw either a period or hash for walls and floors. We should also call the function. In our tick function, we add this here, and oh my god, my head is killing me. It's gotten worse again. Where do we want to put that? Doesn't particularly show it anywhere in anywhere special. So what I'm thinking is we'll do it before that. We'll draw the map and then we'll draw renderables because they'll go over the map. Let map equals self.ecs.fetch. Whoops. That's actually fine, but I got to go back here. So it just looks for anything that matches that, and then draw map. Okay, there we have it. The fetch call is new. We mentioned it above. Fetch requires that you promise that you know that the resource you're requesting really does exist and will crash if it doesn't. It doesn't quite return a reference. It's a shred type, which acts like a reference most of the time, but occasionally needs a bit of coercing to be one. We'll worry about that bridge when it comes time to cross it, but consider yourself warned. Making walls solid. Now, if you run the program, okay, yeah, we'll go ahead and run it. But yeah, we're not going to interact with the walls properly. We're just going to, oops, why did I do that? We're not going to interact with the walls because they're not programmed to do anything. But we, you know, we could walk over them. We have a little cool looking map though. I like it. I actually really like this approach of starting. Like I like this style of map. I did like the last tutorial, but this one has a more classic roguelike look to it, and I prefer that, if I'm being honest. So I really enjoy this. Making walls solid. So now if you run the program, you'll have a green and gray map with the yellow at who can move around. Unfortunately, you'll quickly notice that the player can walk right through walls. Fortunately, that's pretty easy to rectify. To accomplish this, we modify the try move player to read the map and check that the destination is open. So we'll find, there it is, and we're gonna also get the map. Map equal ECS.fetch. File type. And basically, we want to get the destination index. So position x plus delta x plus delta y. So we'll get that index. Oops, not IDs, IDX. We'll get that index, and then if map destination index not equal tile type wall, then we do this code here. We move. Otherwise, we don't move, and there we have it. Now we can't go through walls. So we should already, unless there's something that I'm not thinking about, we should already be good to go. Yep, I'm hitting right, I can't go. Hitting left, I can't go. Easy, just like that. Very quick to add that check. Arguably quicker than the way we did it before in the other tutorial. I feel like this might have even been simpler. Maybe. But anyway, back to the tutorial. The new parts are the let map equal part, which uses fetch just the same way as the main loop. This is the advantage of storing it in the ECS. You can get to it everywhere without trying to coerce Rust into letting you use global variables. We calculate the cell index of the player's destination with let destination index equal position x delta plus delta x, position y plus delta y, and if it isn't a wall, we move as normal. When we run the program, we have a player on a map, we can move around properly obstructed by walls. And we have a full program here. I'm tempted to copy this and just paste over mine, but it should be fine. So a lot of times at the end of a tutorial, I'll do that just to make sure mine looks like theirs. So if they reference the code later, I'm not going to be thrown off by something looking different. But I think we're fine for now. So that was it for walking a map. Very basic starting map generation. Fun stuff though. I like the way it looks and feels so far. I'm happy. So let's go into a more interesting map. In this chapter, we'll make a more interesting map. It'll be room-based and look a bit like many of the earlier roguelikes, such as Moria, but with less complexity. It'll also provide a great starting point for placing monsters. Cleaning up. We're going to start by cleaning up our code a bit and utilizing separate files. As projects gain in complexity and size, it's a good idea to start keeping them as a clean set of files and modules so we can quickly find what we're looking for and improve compilation times sometimes. Also, just my personal aside here, this is something I was really excited for with this tutorial because the last tutorial, admittedly, like it made this point from the very beginning that it wasn't really well organized. It was all in one file, and that was a downside to the tutorial, but it's short enough to be able to just be done in a single file and get away with it. But it was still about 2,000 lines, I believe, and it got pretty unwieldy by the end, in my opinion, where it's like, where is this function? Like, I'm making judicious use of Control F to get to anything, which I mean, to be fair, you probably do that anyway, but it's a lot nicer if you know this code is over here in this place, that code's over here in that place. The other point is, in case it's not clear why it might speed up compilation times, it's because if you haven't touched a module, for instance, that doesn't have to be recompiled. So in C code and C++ code, what you would do is you would separate your codes into different like files. So you'd have like a class or something with its own .h file and .c or CPP file, depending on which language you're doing. So you have like some code in that file, some code and some other C/CPP and .h files, right? And then if you've got like 15 of these different things branched out, but you only touch one of them, when you compile, if you have your make files and stuff set up correctly, you only have to recompile the things that were changed, and so that can help speed up compilation times. As for how Rust handles it, I'm assuming it does the same thing, because like the first time you compile, when it downloads all your dependencies, it's a lot slower, and then from that point on, when you compile, it's much faster, unless you change the dependencies and it has to go pull more in and compile them and such. So we might, I don't know if we'll see any benefit from that here. Maybe, because it does look like you get quite a few modules going on later, but just, you know, something to point out. So anyway, if you look at the source code for this chapter, you'll see that we've broken a lot of functionality into individual files. When you make a new file in Rust, it automatically becomes a module. You then have to tell Rust to use these modules, so main.rs has gained a few mod map and similar, followed by pub use map star. This says import the module map and then use and make available to other modules its public contents. We've also made a bunch of struct into pub struct and added pub to their members. If you don't do this, then the structure remains internal to that module only and you can't use it in other parts of the code. This is the same as putting public C++ line in a class definition and exporting that type in the header. Rust makes it a bit cleaner and no need to write things twice. Yeah, Rust. All right, we're going to look at how it is organized here. And I'm going to just make these changes here. I wasn't really expecting this refactor right now, so it might be a little sloppy. Bear with me. So we have multiple files here. Let's see, new file, components.rs, and we have map.rs and player.rs, and finally rect.rs. Rectangle? What are we talking about? I'm going to open up every single one of these and just see what we have. So in components, we have position, renderable, and player. Position, renderable, and player. So what I'm going to do is I'm going to rip these three out and I'm going to put them into components. And now it's going to be mad because we don't have some imports. So we need use specs, prelude, star, use specs, derive. Not sure why it didn't get mad yet, but that's fine. RLTK, RGB. So we can store the colors in here. That should turn some other color soon. Or it may be mad somewhere else and it's getting hung up. That's fine. We'll work it out. It might be a little bit of a messy refactor as we get this set up, so just bear with me for a moment here. This is the, which file am I looking at here? Main. We'll save main. Map.rs. We'll save that one. Player.rs has only a couple things, so we'll rip that out of main. We have player input and try move player. That's actually it. Then we have the imports though. So player input and try move player. We have use RLTK, and then what are we using? Virtual key code. Whoops. RLTK. We have use specs prelude. We have use super position player tile type XY index and state. And we're using compare min and max. So that super thing is actually not. I haven't done a lot of module stuff in Rust, but when I haven't done this. This is like cross module, and the way I've done it has been a little more explicit. So I didn't realize you could just say use super and you'd grab stuff like that. This is pulling this from map related stuff, I'm sure. Okay, so that's it for player. We need rect.rs. I don't think we've done that yet. I think that's going to be part of the FOV stuff. So we'll hold off on that. And I think the map is going to be maybe doing some new stuff as well. So I wish they would have spent a little more time focusing on how the refactor is done, rather than just be like, look at the code and see, because this is the full lesson code that they have here, not just the refactor code. So it's got things that we haven't done yet. So I'm not a fan of that approach. So mod components, pub use components, mod map, pub use map, mod player, use player, mod rect, pub use rect. That's not in place yet, so we're gonna comment that out. Cannot find player input. Why not? Don't need the derived component in here anymore. We don't need the compare or the virtual key code. So, okay, player has some unresolved imports. They're not coming in with super. That's what I was a little confused by. So let me find how that was being done. I think I closed the player one because I thought I was done with it. So we use RLTK, we use specs, use super, position, player, tile type is coming in. Player should be in components, right? Yeah. How did I do the how are the components done? Maybe I missed something in here. Use specs prelude, use specs derive, do that. Ah, these are pub. Right. When I copied them, I didn't make them pub. Now that's happier, okay. And then that means I need to take a closer look at player and make sure what we have in here is, these are pub functions. You gotta be careful when you're copy pasting like that. Ah, and then the fields also, right. The fields and the components all need pub. All right, that should make things happier. Private type state. Where is state? I think it's still in main. Yeah, so we haven't even got to main yet. I need to do map, so let me do map. That's a big beefy one. First we need to use RLTK RGB. RLTK and random number generator. Use super rect. There is no rect in there yet, so we'll comment that out, but we're going to be using this in the lesson, I guess, so it's good to know. And then max and min. And now for this, what do we need? We need tile type, XY index, and new map. And draw map, I guess. Yeah, draw map is in there. Okay. Oh no, something's mad now. And we're gonna have to make these pubs. Okay. I don't know if we have to do that on the enums, on the enum variants. No, you don't. I was like, that would be a little odd. So we're not using some of these things now, but we will, I guess. So I think that's everything for map now. Player's mad. Okay, so let's get to main now. Main is hurting player and stuff. So this is a pub struct. Pub ECS. And now everything is happy. I love it. Draw map is called though. Okay, I think it was just mad because there were... Yeah, I think state was blocking things from getting detected properly. All right, so I think that's it for the refactor. What we have in main is I have these uses, the mods and stuff. I have state, the impl. Yep. And then I have main, which is pretty much the same. Not much is changing about main. Awesome. Okay. So now, just to test everything out, let's do the refactor, or let's run the refactor. Boom! Everything still works. Now everything's in different files, and I would argue it is already easier to maintain, because what if we want to add a new component? Boom, components, right? That's the you know, beauty of a well-organized project. And I've skimmed through the tutorial. I haven't really read in depth, but I went to some of the really late ones, and I saw how many modules and stuff they have, like how many different systems they have in the game and all that. And I'm like, oh yeah, this is gonna be good, just in terms of the organization. So let's get back over here, and I'm gonna close off these. So I basically ran through all this, and the one we haven't done is rect, which is literally a rectangle with basic collision detection. We have intersections and stuff. So that'll be fun. We'll be doing that in a minute, I guess. Because we're going to be making rectangles for rooms and stuff, right? So, let's see. Alrighty. Making a more interesting map. We'll start by renaming new map to new map test. We'll stop using it, but keep it around for a bit. It's a decent way to test our map code. We'll also use Rust's documentation tags to publish what this function does in case we forget later. All right, so we'll just go over to new map and rename it. And I guess, are we making a new map function? I don't know, we'll see. I'm not going to refactor it, I'm just going to rename it. Because if I refactor it, it'll actually rename it everywhere. Now we've broken the code because there is no new map function anymore. So it makes a map with solid boundaries and 400 randomly placed walls. No guarantees that it won't look awful. I think it looks cool, but it's not really a great map, but it looks cool. So I'm like doing these hard blinks and stuff. Dude, this headache is brutal. This is going pretty quick. We're not even an hour in, but I think I might tap out and not do the field of view one because this is brutal. It like went away for a minute once I started, and then it's like just back. Not fun. So make a more interesting map. Yeah, okay, so we rename that. And in canonical Rust, if you prefix a function with comments starting with // it makes it into a function comment. Your IDE will then show you your comment text when you hover the mouse over the function header. And you can use Cargo's documentation features to make pretty documentation pages for the system you're writing. It's mostly handy if you plan on sharing your code or working with others, but it's nice to have. One thing that's not mentioned here, however, is that you can actually write tests in those comments that can be ran against your code as like quick sanity checks. So now, in the spirit of the original libtcod tutorial, we'll start making a map. Our goal is to randomly place rooms and join them together with corridors. So making a couple of rectangular rooms. We'll start with a new function. So new map, rooms and corridors. Okay. Simple enough. We're going to do that right here in the map. In the map module. So pub function new map, rooms and corridors. And this is a really short one. Let me map equal vec, because we haven't filled it out yet. It'll be tile type wall 80 by 50 map. We're literally just making a solid map for the moment. This makes a solid 80 by 50 map with walls on all tiles. You can't move. We've kept the function signature, so changing the map we want to use in main.rs just requires changing GCS or gs.ecs.insert new map test to, oh, so they did do the refactor. Okay. Well, that's fine. It doesn't matter. So now we're going to change it to this here, and I don't feel like typing it, so I'm going to do that. And let's go over to main and swap that out where it's complaining right there. Why not? Oh, corridors. Oops. That's better. I thought something was wrong with it a minute ago, and I was like, I don't know. Like something was tripping me out, and I couldn't figure it out. Actually, we can run it now. Yeah, that hurts my eyes. It's so green. Yep, so we can't move. And once again, we're using the vec macro to make our life easier. See the previous chapter for discussion of how that works. Since this algorithm makes heavy use of rectangles and a rect type, we'll start by making one in rect.rs. We'll include some utility functions that will be useful later on in this chapter. And so here we are, just going to fill that file in now with the rect info. So pub strut rect, and we have an x1 i32, x2 i32, and a y1 and y2, also i32s. And generally what you are doing is you're defining the upper left and lower right corner, and then that's all you need to have a rectangle. So that's pretty standard. You could define 4 points, but that's wasted memory. Math is easier than memory. And so when we make a new one, we take in a starting X and Y point and then a width and a height, and we can calculate both. We can calculate the other point from that, basically. So You know what? Full struct fields. Maybe that was a bad idea. Maybe I shouldn't have been that lazy. X2 is going to be X plus width. Y1 is going to be Y. And you can guess what Y2 is going to be. Y plus height. Okay, pretty standard way of making a rectangle. And then we're going to make something that returns true if it overlaps with other. We're going to call it intersect. Other and rect. So we take a reference to another rectangle and we return a Boolean. And then this is a beefy one. They put it all on one line, but it's going to look better if we format it. So we'll do that. Self.x1 less equal other.x2 and self.x2 greater equal other.x1 and self.y1 less equal other.y2 and self.y2 greater equal, I'm guessing y1, yeah, other.y1. I literally had to scroll. So that's a big beefy one. Oh, it actually didn't format. Okay, well, we'll just leave it that way. Basically, you're building out a set of constraints. I'm thinking about the easiest way to describe this, because I don't think I want to break down every single point here, but you're building out a set of constraints. And all of these constraints have to be true if they intersect. So the left x has to be less than the right x of the other one. The right x of the starting one has to be greater than the left x of the other one. Right? So, and then kind of the same thing for the y values. And it helps if you draw a picture. If you draw a picture of two rectangles that don't intersect, make up coordinates and make them where they don't intersect, and actually plug those values in, you'll see how this fails, right? So self.x1, let me just double check and make sure I got them all right though, because it is a lot to read. Self.x2 greater equal x1, y1 less equal, yep, y2 greater, yep, that'll, okay, good. So yeah, if you draw that picture out, you'll see that it fails this check somewhere. You can make them intersect in different ways and it'll still fail. And then if you do that again with two that actually do intersect, you can see which parts, like how it actually passes these checks. That's the best way to explain this. And if you were doing this kind of basic rectangular collision detection on your own, you're writing some code or something and you need to do it, you might just look it up online because it's pretty standard. Like, people have been doing this for decades, but I would suggest figuring out, deriving it yourself at least once. And then maybe you don't remember it exactly and you look it up, it's whatever. But it's easy enough, I think, that you can derive it with some pictures and stuff and figure out a formula, or in this case, it's not really formula, but just some checks you can do that would make sense. So anyway, let's do the last function here so we can move on. So we're going to get the center, and that's going to, I guarantee, take advantage of the width and height. Or no, because we don't have width and height. We have the x1 and x2, so we're just going to half that. So self.x1 plus self.x2 over 2, and self.y1 plus self.y2 over 2. Yeah, that's what I missed. I closed the tuple. Alrighty. We're dividing them by, we're taking the average, right? Dividing them by 2, add them together and divide them. Alright, so there's nothing really new here, but let's break it down a bit. We define a struct called rect. We added the pub tag to make it public. It's available outside of this module. By putting it into a new file, we automatically created a code module. That's a built-in Rust way to compartmentalize your code. Over in main.rs, we can add pub mod rect to say we use rect, and because we put a pub in front of it, anything anything can get rect from us as super rect rect. That's not very ergonomic to type, so a second line, use rect rect, shortens that to super rect. Okay, we make a new constructor called new, or entitled new. It uses the return shorthand and returns a rectangle based on the XY width and height we passed in. We define a member method, intersect. It has a reference to self, meaning it can see into the rect to which it is attached, but can't modify it. It's a pure function. It returns a bool, true if the two rectangles overlap, false otherwise. We define center also as a pure member method. It simply returns the coordinates of the middle of the rectangle as a tuple of x and y in val.0 and val.1. We'll also make a new function to apply a room to a map. So we're going to be doing that in a moment here. We'll do it now, but I want to go ahead and make sure we find these places where we had rect, like right here. And now that rect exists, I'm going to simply uncomment that. Right, because it's not in main yet. I was like, why is it complaining? That's why. All right, I think that's the only place that we had it. Wouldn't make sense to be anywhere else. Okay, so now we need to apply room to map. So we'll probably do that right after new map, rooms and corridors. So room and rect, map and mute, tile type. For y in room.y1 plus 1, the room y2, and we're doing an inclusive range there. So we'll maybe talk about that in a moment. For x in room.x1 plus 1, room.x2. So we're going to get the index of the x and y value and tile type floor. So they're no longer walls. We're setting what they are to floor. We're really just looping through all the coordinates of the room, right? We're getting the y1 value and the y2 value of the room. We are doing it inclusive on the edge, which I find interesting. So we are skipping the first value by doing a +1, but we're actually including the end value. So I'm curious to know the justification for that. So we'll see what it is. So I thought before you would do exclusive to make sure you keep walls around the whole thing. But I mean, we are carving these out of a map, so maybe it's fine. And notice that, so yeah, we've got the function in place. So it says, notice that we are using for y in room y1 plus 1 double dot equal room.y2. That's an inclusive range. We want to go all the way to the value of y2 and not y2 minus 1. Otherwise, it's relatively straightforward. Use for loops to visit every tile inside the room's rectangle and set that tile to be a floor. With these 2 bits of code, we can create a new rectangle anywhere with rect new xy width height. We can add it to the map as floors with apply room to map, rect map. And that's enough to add a couple of test rooms. Our map function now looks like this. So let's add that code in there. So we're going to make room 1 rect new 20, 15, 10, 15. Let room 2 rect new 35, 15, 10, and 15. Oh, fat fingering over here. And then we're going to apply room to map. And it's going to be room 1 and mute map. And then I'm going to copy this because it's just going to be room 2. And now we'll run the code. And what do we have? Yeah, we got 2 rooms. That's it. We won, we beat the game. All right, for real though. Let's keep going on. So yeah, if you cargo run your project, you'll see we have 2 rooms not linked together. So now we can make a corridor. 2 disconnected rooms isn't much fun, so let's add a corridor between them. We're going to need some comparison functions, so we have to tell Rust to import them. At the top of map.rs, we'll use standard compare max and min. Min and max do just what they say. They return the minimum or maximum of two values. You could use if statements to do the same thing, but some computers will optimize this into a simple fast call for you. We let Rust figure that out. And we make two functions for horizontal and vertical tunnels. This is very similar to the last tutorial. And it is, they did say it's in the spirit of that tutorial. So that's expected. I already included those at the top when I was doing that earlier. Apply horizontal tunnel when I was making the modules. And I noticed I just put all the uses up there that were showing up. One is an I32, X2, I32, Y, I32. Okay. For X in min, X1, X2, to max of X1, X2. So we're just making sure the range goes from the smaller to the larger. That's why we're using min and max there. Let index equal XY, index XY. If index greater than 0 and index is less than 80 times 50, map index as use size equal tile type floor. We're going to do the same thing now for a vertical tunnel. So it's going to be Y1, Y2, and X. It's going to be almost the same. It's going to be for Y in for Y in min, Y1, Y2, to max, Y1, Y2. We'll get the index with X and Y, and then it's going to be exactly the same. Index is greater than 0, and it's less than 80 by 50. Set it to floor. Then we'll add a call, apply horizontal tunnel, to our map making function, and voila. We have a tunnel between two rooms. If you run cargo run, the project, you can walk between the two rooms and not into walls. So our previous code's still working, but now it looks a bit more like a roguelike. So let's do that. Let's add the horizontal tunnel and give it a shot, yeah? Apply horizontal tunnel and mute map. And the X1 is going to be, oh, it's all hard-coded, so 25, 40, 23. This is a perfectly viable way to test a game and prototype things, hard coding. Here we are. Got a working tunnel. No complaints yet, right? So making a simple dungeon. Now we can use that to make a random dungeon. We'll modify our function as follows. Yeah, so let me just, go back to my little aside there about this being a viable way to do things. A lot of times, it is good to prototype with hard-coded, very explicit numbers that you know what the results are going to be. So the way that they came up with these numbers here is literally based on the hard-coded numbers that were used in making the rooms right here. What you'd really, you just have to think about like what you've hard-coded in and figure out what the right values are going to be. But it can be different for your own game or something. But the idea is, that lets us see that the function works, right? And that lets us get a general idea of how something might look. And then we can go down here and actually modify the function to do a bunch of random stuff and get us a more interesting dungeon now. But, we were able to test those rooms and stuff by hard coding them in initially. So that's what I mean by saying it's a perfectly valid way to do things, because you don't necessarily want to write, 100 lines of code or something and not know that certain pieces are going to function as intended. So basically rip all of this out. We're going to get the map, and then we're going to make rooms. So we're going to make a vector of rooms, vector of rect, and we're just going to do vec new. And let's see, let mute rooms, const max rooms, I32 equal 30, const min size, 32 equals 6, const max size, 32 equal 10, okay? Let mute RNG equal random number generator, new. And then, okay, so here we're not using underscore I, we're just doing underscore. So this is what I mentioned earlier. So we're gonna loop through all the, like, it's weird because we're not looping through something per se, we're looping through a range, right? We're looping through however many rooms that we want to have as our max rooms. And we're gonna make some values. W equal RNG dot range. And it's min size and max size. And this is going to be the exact same thing, except it's a height. So it's h. And then x and y are going to be very similar. So we'll do x, well, very similar to each other. X is going to be 1. And this one here is going to be 80 minus w minus 1 minus 1. We'll have to break down what these values do, maybe. It's one of those where you probably just have to think about it for a little bit. And this is going to be, I bet, 50. Yep. Okay. So then we'll make a new room out of this. Rect new x, y, w, h. Let mute OK equal true. Now I'm not sure what's going to happen here. For other room in rooms dot iter, if new room dot intersect other room, OK equal false. I don't entirely like that. Apply room to map and new room and mute map. Rooms.push. That's a little bit more C-like than I would like to do in my Rust. Making a variable there and then checking against it manually and assigning it like, oh, things are okay, and then checking against that value. You could do something more along the lines of, let's see, rooms dot iter dot so if anything returns true, then this will return true. I don't think there's another one for false, so we would just negate it. So what you do is say any, and you would simply do like other room, and it would be new room dot intersect other room, but this would return true. Actually, no, that's what you want. Yeah. So you're saying if any rooms intersect, so you could do this, just straight up returns a Boolean. Yeah. So if any rooms intersect, then we could put this code in here. Apply room to map. And now if I run that, it should be okay. Nope, I broke it. Maybe it does need to be negated. Maybe I was right at first. No, something weird's going on then. Maybe I'm completely wrong. Let's see. Whoops, let me go back one just to keep that code there. Yeah, what did I miss? Now I'm curious because I went on that aside to say I would like to see something like that, and now not sure what I did. If they don't intersect. Right, we need to make sure it doesn't intersect anything. So we don't want any. We want all. Yeah, that's what I did. We want all. Not intersect. There we go. So I was right at first, but I used the wrong function. So I was right in like, we need to negate it, and then I was like, no, we don't. We're using any. That's it. Okay, so we can do that a little more functionally right there. You be the judge. I think this is cleaner. If all of the rooms don't intersect, then apply room to map and push the room in there. I think that looks a little more readable. Just my take on it. What's going on, Omnivore? But we have it. It works either way. Wrong button. Works either way. Again, if you like this, and it's a little more C-like, where you'd have to manually initialize a variable and check against it. So there's quite a bit changed there. We've added const constants for the maximum number of rooms to make and the minimum and maximum size of the rooms. It's the first time we've encountered const. It just says set up this value at the beginning and it can never change. It's the only easy way to have global variables in Rust since they can never change. They often don't even exist and get baked into functions where you use them. If they do exist, because they can't change, there are no concerns when multiple threads access them. It's often cleaner to set up a name constant than to use a magic number. That is a hard-coded value with no real clue as to why you picked that value. We acquire a random number generator from RLTK, which required that we add to the use statement at the top of map.rs. We're randomly building a width and height. We're then placing the room randomly so x and y are greater than 0 and less than the max map size minus 1. And we iterate through existing rooms, rejecting the new room if it overlaps with one we've already placed. If it's okay, we apply it to the room. We're keeping rooms in a vector, although we aren't using it yet. So running the project, cargo run at this point, gives you a selection of random rooms with no corridors between them. As we just saw, I'm not going to go rerun it. So next we'll join the rooms together with corridors. We'll add this to the if okay section of the map generator. Right, so let's go back to it. I hope you're doing all right, Omnivore. Good to see you here, though. So this would be equivalent to the if okay section. We're not going to immediately push the room, I guess. We're going to have if not rooms dot is empty. So if rooms already has something in it, because we can't draw a corridor to nothing if there's no other, if there's like nothing else. New room dot center. So we just get the center coordinate. We're going to use that to draw the corridors, right, from center of one room to the center of another room. So let previous x, previous y equal rooms, and then rooms.len minus 1. So what we're doing is just manually getting the previous room, so it's not mixing up and like doing random corridors to random rooms. It's current room to the previous room, and it's always going to be that way, at least for now. So if rng.range 0 to 2 equal 1, basically just a Boolean check here. It's one or the other. Apply horizontal tunnel and mute map. We need previous x to new x, and we need previous y. Now I broke this down in the other roguelike tutorial, because it's a little bit awkward to think about initially. So I did break this down before, and we're basically using the we're kind of fixing one value to draw the tunnel. So for horizontal tunnel, we fix the y coordinate and we just slide all the way over, right? And we do the same for vertical tunnel. So we're using those center coordinates to determine where it is we're doing that sliding from and sliding to. So we do that, and we have else, and I'm going to be lazy and copy these. And I think everything will be almost the same. Let's see, previous y, new y, but it's going to be previous x. And here, previous x, new x, and new y. So it's almost the same, but when we flip the order, we change what we're using for that last value there. So there we are. I think everything is currently happy. And there we have tunnels, except we didn't get a room on the player, so we can't walk around, but there we are. Like, it was as easy as that. Nothing to it, right? So what does this do? It starts by looking to see if the rooms list is empty. If it is, then there's no previous room to join, so we ignore it. It gets the room's center and stores it as new x and new y. And it gets the previous room in the vector's center and stores it as previous x, previous y. It rolls a dice. Half the time it draws horizontal and then vertical, and half the time it's the other way around. And then we do cargo run, and it's really starting to look like a roguelike. Alrighty. So next we place the player. So currently the player always starts in the center of the map, which with the new generator may not be a valid starting point, like we just saw. We could simply move the player to the center of the first room, but it's likely that our generator will need to know where all the rooms are so we can put things in them rather than just the player's location. So we'll modify our new map rooms and corridors function to also return the room list. So we change the method signature to pub function. Okay, so we're going to return a tuple of vec_rect and vec_tile type. So let's go ahead and do that. Go. Vec_rect and vec_tile type. And the return statement is going to be rooms and map. That's all there is to that. So, well, we're going to do stuff with it now, but our main also requires adjustments to accept the new format. So in main, where we make the map here, we're no longer simply making it in the ECS.insert. We're actually making it beforehand, so we can just insert the map. We can keep the rooms as a separate thing. So let's go ahead and head over to main. Should be oh no, it's not complaining because you can really insert anything you want into the ECS. But this will break code. I believe this will break code where we try to get the map now. Yep, we crashed because we're using fetch. And remember, fetch in the specs ECS assumes that you are correct and that it actually does exist. So in this case, everywhere that we're using fetch, we're looking for the map. But what we've now inserted here is not just the map, it's two different things. So it does break, which is what we expect. So we'll destructure this tuple so we can get the rooms and the map. We'll insert the map, and then we will say let player x, player y equal rooms 0.center. And then when we make the player, we'll use this x and y value here. Player x and player y. Apparently I'm too lazy to type player again. Don't ask why. Okay. I think everything else should basically remain the same. In fact, the tutorial says as much. This is mostly the same, but we're receiving both the rooms list and the map from new map rooms and corridors. We then place the player in the center of the first room. So wrapping up and supporting the numpad, and thank you so much, and V keys, or VI, whatever you want to call it. So you have VI or V, and you have Vim, which I can never remember what Vim is. It's like V improved. I think that's what it is. I never use those, but sure, we'll do it. Use like L and K and all. We see it right here. I've tried using those keys to navigate Vim, but it just doesn't work in my brain. I really gave it like a solid week of trying to do nothing but that, and I just never got comfortable with it. So anyway, now you have a map that looks like a roguelike, places a player in the first room and lets you explore with the cursor keys. Not every keyboard has cursor keys that are readily accessible. Some laptops require interesting key combinations for them. Lots of players like to steer with the numpad, but not every keyboard has one of those either. So we also support the directional keys from the text editor VI. This makes both hardcore Unix users happy and makes regular players happier. We're not going to worry about diagonal movement yet. In player.rs, we changed the player input to include these extra keys. The good thing is, we're just adding some ORs on our match statement, which is just really easy. Like, nothing to it, right? So I'm going to be lazy and copy this virtual key code : because then I can do that, and numpad 4, and put one more with H. And then here it's numpad 6 and L. Here it's numpad 8 and K. Finally, numpad 2 and J. Very easy. Nothing to it, right? And now I am using the numpad. I instinctively tried to do diagonal movement though, but I'm using the numpad. And if I go to, yep, other keys are working, the V keys are working, VI, and the arrow keys are working. So we are good to go there on all of that fancy movement. And that's about it. The source code for the chapter, yep, we don't need to look at that. But yeah, we have them showing it here in the browser as well, what it looks like. Now, field of view is exciting. This is a bit of a longer chapter, and my headache is not getting any better. So, although it's a bit short, I would have been down to do this one today as well. I kind of wanted to, but I'm not feeling that great, so I'm going to go ahead and call it here. And we'll pick up field of view and maybe monsters on Wednesday. Headaches are the worst, man. I get them way too often. I took medicine and it just hasn't done anything yet. And that's way too common for me. So it looks like, yeah, we could probably do monsters next time as well. We'll do field of view and monsters. I'm going to go lay down for a bit. You know, you would think it would be screen time, but I wake up with these things sometimes. Like they just happen to me. It's been a part of my life for far too long. I don't know. I'm gonna go lay down for a bit though. Flux, is that one of the things that like kills blue light or something? All right, yeah, I'm gonna go ahead and wrap up though. We'll see what Omnivore says about Flux. I think I've heard of it. Yeah, just based. Oh, I've seen someone use that. Yeah, to just based on like your schedule. I knew someone that used that back in the day. There's been a number of years, but could be interesting. Yeah. All right, I'm gonna go and wrap up. So I just want to thank anyone for showing up, watching this on YouTube. You know, you can do all that fun follow stuff here on Twitch, do all the fun YouTube stuff, like button, subscribe, notification bell, all that fun stuff. Leave me a comment. You can leave feedback. Again, it is following someone else's code right now. I am interjecting my own thoughts here and there, though, so definitely feedback is appreciated. You know, how I can maybe do things better or whatever. I think there's going to be a lot that I learn from this as we go. This is very similar to what I've already done, which I kind of knew that going in, but as we get into a lot of the, like, you know, more interesting map gen stuff and down here, like how many chapters is there about map gen and all these different algorithms that we can go through. Like, I'm really excited for getting to that. But even here, I kind of like the feel of this one a little bit more, because it does feel like it's a little more in depth, even though it's doing the same stuff. So I'm enjoying this. And then hopefully, you know, maybe there's that person that, you know, they can't just look at a big wall of text, and having someone kind of narrate it or something helps them out. So I hope it does provide help for somebody. But anyway, as I said, my head's hurting, so I'm not going to do any more of an outro. I'm not going to ramble anymore. I'm going to go like lay down or something for a bit. And until next time, have a good day, have a good night, whatever it is, wherever you're at. Take it easy.